Hello everyone. I would love to highlight on this problem known as the permutation swap. You are going to be given an array, which is going to be a permutations, um, and but it's going to be in an unsorted order, and you're going to have to sort the array. But um, so in order to sort the unsorted order, uh, you are allowed to apply some of the operations here, which is you're gonna have to choose a value, which will be, let's say, a value called difference, and whatever the unsorted array is, what you would do is simply make transitions. You can make swaps, but it's gonna always have to be a multiple of d. That's basically the question actually states. The operations that you are allowed to apply here is basically this value called, you would choose a difference, and you would always have to apply that difference, or should I call it multiple of that difference. You cannot take another values which is not a multiple of that difference. For example, if d is 2, then you can actually um, let's say 5. You can actually do the swapping operations between two integers, between two numbers, only with the difference being 2. Now you can do that multiple times. It does not matter how many times you want to do it. It does not matter. But this has to be the same. And in this way, you're going to finally have to sort the initial permutational array or whatever. Now, the array is going to be unsorted. Of course, the values are not going to be in the same section. What is the best way to perform operations here? What the question actually wants is you have to find out this number d, and it needs to be as big as possible, such that you would always find a way to sort the initial unsorted array. Well, what's the best way to do this thing? Um, you might find out a solution, something like that, where you would find out, okay, I will try to compare whatever the unsorted array is here, its position, with the initials, with the final sorted array's values position. And you would find out what's the minimum difference between two of those respective positions numbers. For example, if let's say 5 was here, 5, 4, 3, 2, 1, you would do, a positional difference of each and every values with the ultimate goal, which was the sorted array. And you would see that, okay, the difference is 4, here the difference is 2, it's 0, it's 2, it's 4. You would also have to check the case for whether the difference is 0 or not. If it's 0, you won't do anything. There could be a possible solutions where you would find out the difference between the real version's position and the old version's position, and you would take the minimum one. But it's not going to give you the best result. It's not the proper solution here. What you're going to have to do, and now you might want to know, why wouldn't that be a solution? I have to figure out the maximum possible difference. I'm trying to find out the differences between the unsorted value and the sorted value's position, and I'm trying to take the maximum one. I'm trying to take the minimum out of all the values, which would eventually give me the maximum one. right? For example, in this case, apart from 0, of course, I could say that 2 is the possible answer. I could I could say that 2 would be uh, the possible answer. Yes, and it is true that 2 is the possible answer here, but not always. Why not always? Well, there could be. Let me take a case. Let's say you are actually finding out in the same way you're trying to find out the sorted values position and the unsorted values position, and you come up with a situation where you have one difference. Let's say one possible D1 is 2, and one possible D is 3. Now, and one possible, let's say, is 4. I'm talking about the difference. These are the differences of any sorted values position with the unsorted values position. And you would notice that why I'm saying that the minimum value here, what's gonna be the answer, by the way? What will be the answer of this? If there's a situation, just imagine a situation, you get the difference 2, 3, and 4, and you would see maybe there are other values, but let's just, for the sake of simplicity, let's just imagine that we have the 3 values. And if you say the answer, okay, I'm just going to take the minimum one equal to 2, it's not. It is not the answer. The real answer would be 1. Why is that? It's because it needs to be whatever the difference is, that those differences needs to be multiples. But whatever the maximum value, that maximum difference that we're finding out, it has to be the multiple of all the differences that you've found out, apart from 0, of course. So apart from 0, each and every values common divisor should be the answer, and as we are required to find out the greatest possible differences, we would find out the GCD of those values. Now you might say, why are we going to do GCD? It does not make any sense. Well, it does make sense because let's say two numbers, difference is 4, and you might say that, okay, I know my possible answer can be 2. I can guarantee that. How? You would swap those numbers first with the difference of 2, and then you would swap it again with the difference of 2. In total, it becomes 4, which is a multiple. So 2, because 2 is a multiple of 4, right? But can you say the same thing for 3? Can you say the same thing for 3? That's my question. Can you do something like that? If you're saying the answer is 2, and yes, you were right when we were saying that if the difference is 4, I could just swap it and divide it into 2 operations of difference 2, right? I could just swap here to there, and then here to there. Overall, it's 4, right? I could make it happen, but it's not possible if you say the answer is 2, because if the difference is 3, how would you be able to do and perform swaps having the difference of 2? What I mean by is that, okay, let's say you have managed to swap it out. 2 positions have gone. But when you do them, again, you're going to have to stick with the same possible differences. That difference has to be 2. You cannot reduce it. It's not possible. That's not the requirement. The requirement always says that the difference should always be the same. And Definitely, you can apply multiple of those, but that will be multiple. And so 2 is not a multiple of 3. So that's that's one case. So what would you do? What is the best possible answer? You would say that I need a number. Really, I need a number that can be divided by all of those differences apart from 0, of course. But it has to be such a number that is much more greater as possible. As great as possible. What is that number? That number is basically the greatest common divisor. And that's exactly what we did to figure out the answer. I would take a journey to the problem itself, the solution. It's very simple. What you would do, simply find out the sorted values position versus the unsorted values position, unsorted arrays values position. You would check and you would just find out the GCDs. That's the answer. Here, as we are calculating the GCD, it's of course it's going to be the prefix GCD, you know, all of those differences GCD. 0, I'm not actually tackling the cases for 0 because whatever number that you perform GCD with 0, the C++ library function always provides that number itself. It does not give 0. So I could just, simplifyingly, generalizingly do this thing and provide the answer. That is just how you would solve this um, beautiful problem. Oh, yep. Thank you very much for watching.